8.3, Factoring Trinomials. In the previous two sections, we saw what happened when you were able to simply factor one term out front from two. And then we most recently saw how to factor through grouping. And so those grouping problems more often had 1, 2, 3, 4 terms. Here we're factoring trinomials though, so they have 3 terms. And like I said in these sections, you don't want to gloss over these sections because the differences between each type of problem can be so subtle that by the end of the chapter, if you're taking a test or trying to actually do problems with application, you might fumble along the way. Now this first 8.3 section, you'll notice that it says factoring trinomials, but they have to be in this form. And so on the notes, I've written this or typed this larger because out front there isn't a value that's shown, so these ones are only going to work when the value out front is the value of 1. So in the next section, you'll actually have values out here like 2. And so you'll notice that this says B and C, and that's because this unspoken 1 value right here is the letter A. So these are standard form trinomials. Something standard is what you're normally seeing. Okay, here's the first problem we'll end up looking at. X squared plus 5x plus 6. And so really repeatedly, you want to say this to yourself. What are the factors of C that add up to B? So that means you're looking at the last number for the factors so that they'll add up to that guy here. So I've moved this up. So what are the factors of C that add up to B? I wouldn't do this for every problem, but it's got to be in the form of x squared plus bx plus c. So over here on the left side, let's label this problem 1. And I'm saying, what are the factors of C? Well, for the trinomial x squared plus 5x plus 6, it's the factors of 6 that add up to 5. And let's think of all the factors of 6. The only way I can get 6 is by 1 times 6 with multiplication or 2 times 3 with multiplication. And when I go through and try to see which of these add up to 5, 1 plus 6 is 7. That doesn't work. 2 plus 3 does work. And the cool thing is, all you have to do is, now that you've done that work, you're going to write this as x plus 2 times x plus 3. So it's like we're going back to where we would have had an older FOIL type problem. And that's how we would get there. Now, speaking of FOIL, I'm not going to have you write these out, but the first would give me my x squared term. The outer and inner would give me 3x and 2x. There's my 5x. And then the last would give me 2 times 3, which is 6. So factoring is very much a procedural way. It's kind of like you just learn the steps. This is a procedural way of figuring out how to do these problems. So here we have x squared minus 10x plus 16. The previous problem was a little bit more straightforward because we didn't have to toss around different numbers and combinations here. But when we have a negative involved, we're going to ask ourselves something slightly different. For the problem x squared minus 10x plus 16, we're looking for the factors of 16 that add up to negative 10. For these early problems, I'm going to be exhaustive with how I look at these. But I really later might not show any of this work. 1 times 16 gives me 16. Now, no matter the combinations of negatives and pluses and whatever, these 1 and 16 would either add up to 17, positive 15, or negative 15, or negative 17, trying all those different plus plus, minus minus, plus minus, minus plus combos. So maybe I move on to the next set of factors. 2 times 8 equals 16. Well, 2 plus 8 would give me 10. Negative 2 plus 8 would give me 6. Negative 8 plus 2 would give me negative 6. But the one that is the best to land on will be negative 2 plus a negative 8. So both factors would have to be negative here. So let's see if that works out okay. So for this one, it's going to be negative 2 and negative 8. So I will write both of these with subtraction symbols. X minus 2 times x minus 8. And if I FOIL this one out, there's my x squared. Negative 2x and negative 8x give me negative 10x. And then negative 2 and negative 8 give me positive 16. And if you're not checking these, you're going to end up building up mistakes, and you got to be sure you're being thorough on these early problems until they feel really comfortable. Well, I just realized I did these problems out of order, and that was really problem 5. So let's do problem 2 now. Okay, we got x squared plus 6x plus 8. And I'm not writing this out every time. I just did it for the first problem, but it'll be my place to write in if I want. So what are the factors of 8 that add up to 6? So here I won't bother writing anything else down. Well, 1 times 8, that's not going to get me 6. 2 times 4, that sounds good. X plus 2 times x plus 4 gives me x squared plus 6x plus 8. Here's the x's colliding. 4x and 2x gives me 6x. And then 4 times 2 gives me 8. Again, I'm modeling how you want to check all these problems as you do them. Number 3. I honestly really dislike A's. I find that factoring suddenly becomes challenging for me. So I'm the type of teacher that has no problem with you changing the variables to something maybe you like a little bit more. So I'll change this one to y's. So I'm looking for the factors of 15 that add up to 8. Now maybe immediately you're like, well, it's got to be 3 times 5. And if you feel that way, just jump right into these. These get to be pretty procedurally rote. And the word rote means you kind of just perform them like muscle memory. You just kind of plug and chug through these. And since those are both addition, I'm not going to bother talking about it. Problem 4. 9 plus 10t plus t squared. I don't like that. I'm going to change it in the order that I like to see. T squared plus 10t plus 9. It is in descending order. So what are the factors of 9 that add up to 10? 1 times 9 gives me 9, and 1 plus 9 gives me 10. If I were to try 3, that would not work at all for this problem. So I'm going to write this as t plus 1 times t plus 9. Now pause the video to do a FOIL check in your head, because I'm moving on. 5 we've already done, and here is 6. All right, this one, 21 minus 22m plus m squared, that's shuffled around again. So I'm going to write the variables in descending order. M squared minus 22m plus 21. I'm looking for the factors of 21 that add up to 22. So this gets a little bit weirder, but I know that I think of 3 times 7 as factors of 21. But even if I made them both negative, I would not be getting very far, because negative 3 minus 7 would get negative 10. And we are targeting negative 22 for the value that we want these to add up to. So it just seems reasonable to me that we're probably going to be stuck with 21 and 1. And the way that I'm going to get this to work out and add up is if they both are negative. So negative 1 plus a negative 21 would give me negative 22. And when I write this out, I'm going to write m minus 1 times m minus 21. And if I were to FOIL that out, I'd be golden. I think that at this point, we've done quite a few examples. And when I look ahead, I would say the rest of these are fine as OYO problems. So make these on your own and go ahead and use Wolfram Alpha as a resource. And what you're going to end up typing into Wolfram Alpha would be the word factor, and then you could type r squared minus 2r minus 24. And the way that you're going to get that exponent in Wolfram Alpha is by using the caret button. R caret 2 would put an exponent. And after you type that in, it'll show you what it thinks you typed in, so you can see if it did a good job with you or not. The great thing about being able to factor these is then it's going to lend itself to actually solving these factoring problems. But we're going to save that for a separate video to make sure that just straight up factoring trinomials feels great. And don't be short on these. Make sure that you do enough of these to where they feel very, very, very routine.